Hey guys, welcome back. Today I would like to show you how to run Claude Code completely free on Windows. Now if you don't know about the Claude Code, it's an Anthropic AI coding assistant that sits in your terminal. Normally it talks to Anthropic paid Claude API which costs money every time you use it. And this is exactly we are going to solve in this video. We are going to redirect those requests to the local model running on the same machine using LM Studio. Now here is what this makes video a little different from the other setup tutorial. I'm going to cut the hype and show you exactly how this works behind the scene. We are not just going to click through the installation step. I'm actually going to open the developer logs and show you why a simple prompt generates a massive tokens in the backend, how that affects your response time, and most importantly, how to tune and optimize your local environment to get a response 6x faster, completely private, no data leaving your machine. So by the end of this video, you know exactly how to set up Claude Code locally, but more importantly, you will actually understand how it works under the hood. I'm on Windows 11 with 32GB RAM and no dedicated GPU, so you can absolutely try this on your laptop without needing anything fancy. I kept this video very beginner friendly so that you can follow if you are just starting your AI journey. Alright, if that sounds interesting, let's get into it. Alright, before installing anything, let's quickly understand the architecture and what we're building. So here, Claude Code sits in your terminal as a coding assistant interface. Normally, it sends your prompt to Anthropic Cloud API and that costs money. But instead, we are going to point to LM Studio running on your machine. LM Studio acts as a local server. It loads the AI model and exposes it through the local API that Claude Code can connect. So the complete flow is Claude Code sends the request, LM Studio receives it, local model generates the response, and the result returned to the Claude Code. So everything stays on your machine, no internet required for actual AI processing, no API cost as well. Alright, so let's run the model locally. So first we need the LM Studio. Just download the installer from the official website and run it. So once it's installed, you will get a nice beautiful dashboard here. And there are some initial setup required which are covered in our previous video. I'll put the link here. So inside the interface, you will get the option to browse and download the open source language models. So one of the important feature here is the local servers. So when you start the servers, LM Studio exposes the running model through the local API endpoint. This allows the external tool to send the prompt to the model programmatically. So and this is exactly how we will connect Claude Code into our local model. So now before you download the model, let's quickly understand what all these options actually mean. Inside the LM Studio, you will see all the popular open source model, and it can be a bit confusing first. So you'll notice most of the models comes in a different size. For example, if I search with Qwen family, you'll see variant ranging from very small models to extremely large one. And these numbers like 0.8b, 2b, 7b, 14b or even 17b, which represent the number of parameters in the model. In simple term, parameter define how much the model has learned so that you can get better reasoning engine. So generally, smaller model is faster and lighter, and larger models are more capable but much heavier to run. For example, 1 to 2 billion parameters model can usually run on CPU. 7 billion parameter model starts getting slower on CPU, and anything above typically need GPU. If you scroll on further, you'll find models with tens and thousands of billion parameters that are very powerful, but they require serious hardware, often GPU with large amount of VRAMs. So the most local setup, especially on the laptop, usually work with the smaller models. And since I'm on Windows, I'm going to use GGUF format, that's a quantized format that runs efficiently on CPU. Tools like LM Studio uses engines like llama.cpp under the hood to run these models, even on CPUs. Now this part is important. You will see multiple versions on the same model. These are different quantization levels. Quantization is basically the way to compress the model. It reduces the precision of numbers inside the model so that it can use less memory. You can think of it like high precision means better quality but more memory usage. Lower precision means smaller size, faster performance but slightly lower quality. For example, Q8 is higher precision, better quality but heavier. Q4 is much smaller, faster and easier to run locally. And the most local setup, especially without GPU, quantization models are essential. For now, the big question is which model we actually use. So for this demo, I'm going to choose a smaller model so that it can run comfortably on CPU. So Alibaba recently dropped Qwen 3.5 model, and we'll go with 2 billion parameter model. It's not the most powerful, but it is slightly enough to run the locally without GPU. Now that we understand the model size, format, quantizations, let's download this model and run it locally. So once the model is downloaded, click on New Chat. It will load the model and open a chat window. Before loading the model, let's quickly look at the few important settings here. LM Studio is showing the estimate memory usage, including both CPU and GPU. In my case, I don't have dedicated GPU available for the inference, I'm going to explicitly set GPU offload to 0. This ensures that entire model runs purely on CPU. This is important because the performance we observe later will be completely CPU bound. And you will notice the context window length is set to 4096 tokens. This means that model can process only 4096 token in a single request. So right now we have a clean baseline setup. This model is running entirely on CPU with a limited context window with the default performance settings. Now let's load the model and see how it behaves. So in the chat window you can see the model is loaded. So just type something simple. Let's say hi, and you can see we are getting an immediate response. So our local LLM is working perfectly. So at this point we have verified the model is running inside the LM Studio, but it's only accessible through this interface. Now to connect this model to external tools like Claude Code, we need to expose it as an API. So let's start the local server. So when you start the servers, LM Studio exposes an endpoints, usually something like http local address 1234. This may mean that any tools in this machine can now communicate with this model. And you will notice a log appearing here. This log shows local API request being made, including the token usage and the timing. And we'll use these logs later to understand the performance issue. At this point, LM Studio is essentially acting like a local version of Cloud AI API, but running entirely on your machine. Alright, let's set up the Claude Code. So Claude Code is an Anthropic AI coding assistant that lives in your terminal. What makes it really different from the regular chat window is that it can read your file, write code directly to the disk, run the terminal command, and plan the multi-step tasks. Think of more like a developer you are pairing with rather than a chatbot. So let's go to anthropic.com, click products, select Claude Code, and you will find the installation command for the Windows right there. So open the PowerShell and run this command. Just make sure that Node.js and npms are installed first, and installation is quick, and we got a version 2.1.78 loaded. Now here we need to set up two environment variables to connect Claude Code with LM Studio. So let's set them up directly in the terminal first. So first is a base URL. This is exactly the IP address we just saw in the LM Studio. And for the authentication token, in the normal setup this would be a real API, but since LM Studio doesn't actually need an authentication, any strings works here. We just use LM Studio to keep it clean. Before we launch, let's quickly verify the model name using the API, and that return our local model we have loaded on the LM Studio. Now let's go ahead and launch it using the Claude-model command followed by the model name. There is a one-time setup to set up the profile. Pick the mode as a dark, touch the folder, yes to the existing key, and we got a nice Claude Code terminal here. If you type / you will see a list of useful command. Type /model, it confirms we got a Qwen 3.5 2 billion parameters selected. And you will also notice Anthropic cloud models listed here: Sonnet, Opus, HiQ. We are going to ignore all those things right now and going to use our local model. So here is something really important. The environment variable we set is going to reset every single time you open a new PowerShell window. So let's save them permanently here. So let's exit the Claude Code terminal first, then open the profile file in the notepad. If the profile file doesn't exist, create it first using this command. And you'll find all the related commands for this video in the GitHub page. I'll drop the link in the description. Now update the profile with these two environment variables first. Then add a function which is basically a shortcut. So instead of typing the full command, which is Claude-model, then the model name, you just need to type Claude-local, which will load the model automatically. Finally, let's reload the profile in your current PowerShell session so the new settings and the function can take effect immediately. So pretty much we are done with all the configuration here. Let's launch it using the local command. Great, we are in. So we have set up the LM Studio and the Claude Code terminal. Alright, let's go ahead and run our first test here. Explain what is REST API in one sentence. So let it run from the terminal. Meanwhile, we'll jump into the LM Studio. So let's switch over to the LM Studio and we can see it started processing the request. But there are a few interesting things happening here. The progress is going up and coming back. And sometimes the model gets rejected and auto-reloaded. So something clearly strange going on here. Now let's look at the developer logs, which are pumping out a huge amount of logs at this time. If we filter with just errors, look at this one right here. So these are the two numbers we need to have a close look. First is n_keep, which is around 19702 currently. This is the number of tokens sent by the Claude Code. Then the n_ctx, which is 4096. That's the maximum number of context window can hold right now. Previously, 19702 simply can't fit inside 4096. That's why the model rejects the request instantly, which is why you see the ejection out and reloading every few seconds. And look at what Claude Code also showing us. Error code 500, the number of tokens to keep from the initial prompt is greater than the context length, and the same number show up here. And returning every few seconds, attempt 9 out of 10 times. So both sides telling the same story. The request is too big for the default context window. So basically we just type around 10 words, but look at what Claude Code actually sent to the model, around 19,000 tokens, right? So where did that all come from? So let's break it down. So when you launch a Claude Code, it doesn't just send your message. Every single request it sends has a massive system prompt along with it. And that system prompt has 4 major parts. First is the system instruction. It's about 4,000 tokens. These are the rules and the behavior guidelines baked into the Claude Code. And second is a tool definition. This is a big one, about 11,000 tokens. Every tool's Claude Code has a read file, write file, bash and edit, and each one has the full description, what it does, what inputs it takes, what it returns. The model needs all that to know how to use them. Then comes to the conversation history, about 4,500 tokens. It consists of all our chat history. Then finally our actual message, about 10 tokens. So you type this one, Claude Code added everything else. Now the big question here is, how do we fix them? First, let's go to the LM Studio, click on loaded model, find out the context length. Set it to anything higher than 19,000 in our case. So we'll set it 32,000 here, which gives Claude Code enough room to actually fit into the full system prompt. And reload the model. Now one more thing, the timeout. So by default, Claude Code give up after the 60 seconds. But processing 19,000 token on the hardware takes much longer than that. So we need to extend it to 5 minutes. So let's update the profile and mention them in milliseconds. Alright, let's reload the shell and launch. Great, we'll go ahead and test the same prompt again and switch to LM Studio. So an API request has been received from the Claude Code and the request being processed now. And look at this time, a steady progress happening from 2.6 to 5.2 to 7.8. No errors, no ejection. This is what success actually look like. So what's happening here is the model is reading the Claude Code system prompt in batches of 512 tokens at a time. Each batches take around 15 to 60 seconds on this hardware. So at 2.6, that's the first 512 token processed. At 5.2%, that's the second batch done. And it will keep going like this until it hit 100%. Then it generates the actual response. And finally, there it is. We got a response on the Claude terminal. REST API is an architecture style for building network applications that uses HTTP method and standard web protocol to define how data is transmitted between the client and the server endpoints. And the response time is 12 minutes and 50 seconds. So it's really worked, but why it took 12 minutes? So let's understand this because I think it's actually really interesting. So Claude Code sent around 19,653 tokens to the LM Studio. The model can't process all that at once. Trades in batches of 512 tokens at a time. So 19,653 divided by 512, that's 38 batches. And each batch takes around 16 seconds on this hardware. So 38 batches times to 16 seconds, that's 608 seconds. That is roughly 10 minutes just to read the prompt. Then generating the actual response takes another 2 minutes. That's your 12 minutes right there. Think of it like reading a book, 2 pages at a time, where 2 pages takes around 16 seconds. And you have to get through all the 38 sections before you can answer a single question. A quick note, if you're on the machine with a dedicated GPU like M4 Mac or NVIDIA card with VRAM, those same 38 batches would process it in seconds instead of minutes. The math exactly the same, the hardware is just drastically faster. So on this CPU only setup, we are doing it in the hard way. Great, I hope you get the point. Now let's ask one more prompt right away without restarting the current terminal. Write a Python function to reverse a string and look at the response. It took 8 minutes and 20 seconds, noticeably faster than the previous one. If you look at the LM logs here, n_past is 15878. That means the model is already had 15878 tokens in its context from the previous prompt. When the new prompt came in, the LMR CPU tried to match it against a saved checkpoint. The checkpoint at the position 16383 didn't match the new prompt and was discarded and fell back to the checkpoint at 8191, which is still valid, and reprocessed from there. So about 11,500 tokens instead of full 19,700. Same model, same hardware, just less work to do. That's a checkpoint effect. Think of checkpoint like a save point in the video game. Instead of replaying the entire level from the start, the model just reload from the last valid save and continue from there. The longer you stay in the same sessions, the faster it gets. Alright, now let's jump into the most interesting part of this video, how we can optimize this further. First, let me update the profile quickly. I'm adding a second function called Claude Agent that runs the Claude Code with the full tools enabled. Now we have two shortcuts, Claude-local, fast mode, tools disabled, Claude-agent, full agent mode, all tools. Let's save the configuration and reload the profile. On the LM Studio, turn off the local server and restore the context length back to 4096 and load the configuration and restart the server again. Now launch the Claude Code with the Claude-local. Alright, let's test with the same prompt again. Let's switch to LM Studio and you will see two slots running. It's normal. Claude Code sent the internal request along with your actual prompt. You might see a brief KV cache warning in the logs with the context at the 4096. The two processes briefly compete for the memory. LM Studio automatically purge one slot and retry with a smaller batch. It recovers on its own, nothing to worry about. The important number here is n_key, which is 3256. Compare that with 19653 before. This reduction is roughly around 16,400 tokens. And here is why it is that big. -- tool is none doesn't just remove the tool definition. It also strips out the tool related system instruction that are baked into system prompt along with them. So both these pieces disappear together. The response came back 2 minutes 3 seconds. 2 minutes instead of 12 minutes. Great. Now here is why exactly this happened. Default mode is 19653 token. 38 batches 12 minutes. With the -tool none, that is chat mode, around 3255 tokens. Just 7 batches 2 minutes. Around 5x fewer batches equal to 5 to 6x faster. Same model, same hardware, same question. Only difference is tools disabled. Since Claude can actually do things like read files, write file, run commands, every tools need a full instruction manual baked into every single request. More capability is equal to bigger instruction. Now let me quickly show you the system resource while this is running. Open Task Manager. The LM Studio sitting around 2.5 GB. That's a model weight plus the context memory. Claude Code itself only about 350 MB. It's a very lightweight terminal. All the heavy lifting happens inside the LM Studio. Alright, so before we wrap up, let's do a quick side-by-side comparison. Claude Code versus VS Code continue we built in the last video. We will change the context length to 8000 so that continue as well as the Claude terminal can send the request. I have continue open here, connected to the same local model through LM Studio. It auto-detected same prompt to both. Write a Python class for a stack data structure with a push, pop, and peek, and isEmpty method. Include error handling and docstring. So continue responded noticeably faster, and Claude Code came back with more detailed, full docstring, better error message, and cleaner structure. And here is my honest comparison. Continue is fast, lightweight, great for the quick question and inline completion. Claude Code in chat mode slightly slower but noticeably better quality response. Claude Code on full agent, slow start but can actually write files, read your code base, run the commands, completely different capabilities. So pick based on what you need in that session. Great, so we went from zero to fully working local AI coding assistant, opened the logs, understood the tokens, and made it 6x faster. So that's the difference between just following the step and knowing why they work. Local AI is moving fast and setup like this is only getting better. All the commands and the steps for this video are on the GitHub, link in the description. See you on the next one, take care.